Hi, in today's video, we'll have a look at the f-test. Now, until now, we looked at t-tests, and t-tests are great to test the significance of a coefficient of each variable individually. But if you want to test the joint explanatory power of different variables, then you need to look at an f-test. So let's look at how we set a null hypothesis when we carry out an f-test. Well, let's say that we want to check if our model has any explanatory power. So the way we're going to set our null hypothesis is to see if we have enough evidence to disprove the fact that it has no explanatory power. So my null hypothesis is that beta 1 is equal to 0 and that beta 2 is equal to 0. Because if both coefficients are equal to 0, then neither x1 nor x2 has any explanatory power, and therefore my model does not have any explanatory power at all, because those are the only two variables that are included in my model. Now, the alternative hypothesis is always the opposite of my null hypothesis. So here it will be that at least one of the coefficients is different from 0. So at least one of those parameters, beta 1 or beta 2, has to be different from 0. And here, one thing that I want to stress is that when you negate and, or when you take the opposite of and, it is or. A very common mistake would be to write your alternative hypothesis as beta 1 is different from 0 and beta 2 is different from 0. But the negation of beta 1 is equal to 0 and beta 2 is equal to 0 is beta 1 is different from 0 or beta 2 is different from 0. So how is the F statistic defined? Well, F will be equal to R squared, which is a measure of the explanatory power of the model that we saw in a previous video, divided by K minus 1, where K is the number of parameters that are being estimated in our model. So remember, in our model, we had three parameters that were estimated. There was alpha, beta 1, and beta 2. So K is going to be equal to 3. And then we divide by 1 minus R squared divided by N minus K, where N is the sample size. Right? So here there are two types of degrees of freedom that we need to compute to calculate the to know the F distribution, and that will be the K minus 1, and it will be the N minus K. Okay, and here I'm showing you different distribution depending on the different values of the degrees of freedom. So for example, here, if you have for the first degrees of freedom value of 1, and for the second one also a value of 1, you get this distribution. Okay. Whereas if you look at d1 is equal to 100 and d2 is equal to 100, then you get this one. So you can see that you get extremely different patterns depending on the degrees of freedom. Okay, or if you have d1 is equal to 5 and d2 is equal to 2, then you get something like this. Now, in our example, we had h naught, which was beta 1 is equal to 0 and beta 2 is equal to 0. And our alternative hypothesis was beta 1 different from 0 or beta 2 is different from 0. So the F statistic is R squared divided by 3 minus 1, because we have three parameters that we estimated, divided by 1 minus R squared divided by 757, the sample size, minus the number of parameters we estimated. And the R squared of our model was equal to 0.6405. So when we calculate the F statistic, we get a value of 671. Now, under the null, that means assuming the null hypothesis is correct, the distribution for the F statistic is as follows. And so now, since we know the distribution of the test statistic under the null hypothesis, we can calculate the p-value. And we're basically going to see what is the probability that we get a value that is higher than 671. Now you can already see that this is going to be very, very small, okay? Because here already at 5, the area that is under the curve for values greater or equal to 5 is already super, super small. So the p-value is actually less than 0.0001. So we reject the null hypothesis that our model has no explanatory power. Okay, so that was a gentle introduction to F statistics. We'll see that there are different types of F statistics that you can compute for different types of tests. Here we were just looking at the explanatory power of the entire model, but you can also use F statistics to just look at multiple hypotheses that concern, let's say, 2 parameters out of 6 parameters that you estimated in your model. And it will be a variation on the formula that I showed you. So that's it for today's video. And in the next video, we'll have a look at multicollinearity.